Good morning. I am Prasannanjaneya Reddy, working as Assistant Professor in the Department of ECE, IARE, Hyderabad. In this session, we are going to discuss about task communication. For this topic, we need to refer Introduction to Embedded System by Shibu KV. Task communication. So, while doing the operations, one task or process may require the information from other process. That is called, at that time we need to provide the communication among various tasks. So in this session we are discussing in detail regarding this. First, in a multitasking system, multiple processes run parallelly. So at a time we are playing the VLC player at parallelly. We can do the Word document work or PPT work or running the codes behind that one. Like that, we are doing multiple operations at the same time, sometime in some conditions. At that time, one process may be or may not be interact with the other process. So based on the interaction between these two processes, we are categorize the process. One is cooperating process. Cooperating means one process may require the data from the other process for completion of its operation. Means if you want to do the task 2, that depends on the task 1 response. So, that is cooperating process. Second, competing process. Competing process means they do not share any information. They are sharing the resources like common memory, common output devices, or additional hardware or communication peripherals. That type of thing is called cooperating or competing process. In cooperating process, exchange information and communicate them one to another, communicate with one to another in different manners. We will check one by one. So through sharing, we can share the information. Cooperation through sharing. So the cooperating process exchange data through shared some resources. So no data is shared between process, but they communicate for synchronization. That is called cooperation through communication. If you want to share data, first we need to establish the communication. For that we are using different synchronizing techniques. For synchronizing two processes, you need to give some data. That is also one type of communication. The mechanism through which processes communicate each other is known as inter-process communication. So there are various inter-process communication methods. We will check one by one. First one is shared memory. Here we are placing one common memory for sharing the information among various processes. The process which wants to share the information, that process writes the data into the common memory. Whatever the memory space, we are arranged for sharing the data. So, for example, notice board. So, the administration will send the circulars or whatever the information they wants to interact with the students or faculty. That information is placed in the notice board. the information required people like students and faculty or staff, non-teaching or teaching staff, whatever may be, they are seeing the notice board and follow that instructions. Like that, the process wants to write the data, that is called server. The process which utilizes that source content, that is called client. That means it will process the server client method. Okay. In pipes, example one of the shared memory is pipes. So it follows the client server architecture. So a process which creates a pipe is known as pipe server. And a process which connects to the pipe, that is known as pipe client. So this pipe has two ends. Suppose this is considered as a pipe, it has two ends, one end and another end. So once there are two types of pipes, unidirectional pipe and bidirectional pipes. Unidirectional means in one direction. Suppose I want to share the information, that information is writing at this side, one end. Another side, another process which wants to read the data, that reads the data at another end. So data from one end to, left to right, in one direction only. So in the left side, the process which wants to write the data. In right hand side, the process which wants to read the data, that is reading from right hand side, writing from left hand side, like that. That is called unidirectional pipes. Bidirectional pipes means at one end, only left hand side, the process which wants to write the data, that write the data into the memory. The process which wants to read the data, that is also reading from left hand side, from the shared memory. That type of pipes is called bidirectional pipes. So here we are writing the data at the left hand side and reading the data at the right hand side. This is the common fixed memory or shared memory. Okay, like this the process will share the data. Here two types of pipes is there. First one is anonymous pipes. In this condition, those pipes don't have any name. Unnamed pipes, that is called unnamed pipes. That is called anonymous pipes. In anonymous pipes, in unidirection only, the data will be shared. Means writes the data at the left hand side to the common memory and read the data from the right hand side by the desired process. Okay. In case of named pipes, there are two types of, it supports both directions. It contains unidirectional pipes at the same time it supports the bidirectional pipes. The named pipes means that contains some name. Those pipes may transfer the data from in one direction only or in both directions at the one end only. Okay, like this. Next, memory mapped object. So in this condition, some fixed memory space is allocated for the sharing the memory. If you see this one, this fixed memory, 4 zeros to 8000. This fixed memory is defined for sharing the data. From this data, the process which wants to write the data, that is mapping to its virtual memory space. First, it maps the virtual memory to the fixed or physical memory. That map the virtual memory to the physical memory. So in this, it wants to write the data means write the data. And read the data means, again, the process which want to read the data, that is maps its memory space to the physical memory. So mapping the virtual memory to the physical memory. So the process which wants to write the data, first map that one and write the data to the physical memory. Okay. The process which wants to read the data, that read, first map this memory space to the virtual memory space to the physical memory and read that data. In this manner, the memory is mapped to the virtual memory and do the read and write operations. Next, message passing. So message passing is an synchronous or asynchronous information exchange mechanism used for inter-process communication. So the major difference between shared memory and message passing is, in the shared memory, we can share bulk data at a time. Once the memory or both memories are synchronized, we can share bulk data. Like we are connecting our pen drive to the laptop and share GBs of data. In case of message passing, the data is limited, like only 8 bytes of data in a single frame, are based on the data size in that communication peripheral frame format. Suppose I am taking I2C communication bus. In that frame, we can send 1 byte of data at a time in a single frame. In case of control area network bus, if you look at that frame, in that frame at a time we can transmit 8 bytes of data. Just compare. 1 GB of data is transmitting is different, 1 byte of data is transmitting is different. How much difference is there? Suppose GB means 2 power 30 bytes. So 2 power 30 times more data is transmitting. Just imagine how much time it will take, or how much space required, or what are the positives and plus and minus. Check here. Okay. So message passing also synchronizing relatively fast and free from the synchronization overheads compared to the shared memory. Based on the operation between the processes, this message passing is different types. First one is message queue, mailbox and signaling. Okay, we will check one by one. Message queue, like we are sending a messages in like SMS. So the process which wants to send the message, it will send ID, comma, data. This is sender ID. So means the device wants to which device we are sharing the data. Receiving process ID. To which process you want to share that process ID, and whatever the data I want to send, the data will be defined in this message. In the same manner, that is posting to the message queue, that size is limited. Then from this message queue, the process wants to read the data, it will receive the messages. Like this receiving message contains from which device we are getting the message, that is transmitting process ID, comma, date. Okay. So messages are sent and received through send and receive. Like send message contains name of the process to which the message is to be sent. Similarly, it will receive the message that contains name of the process from which the message is to be received. Okay, by using these two methods, send method and receiving method, the messages are exchanged here through a message queue. Through a message queue. So a thread which wants to communicate with another thread posts the message to the system queue. The kernel pick up these messages from the system message queue one at a time and examines the message for finding the destination thread, and then post that message to the message queue of the corresponding thread. Means each process having some message queue. In that, the kernel fills these messages like a postman. So I am posting some message in the post box. The postmaster divides the message, covers into the different destinations based on the pin code. Like that, this kernel pick these messages from the message queue and distribute that message to the corresponding messages, process IDs. For posting a message to the thread message queue, kernel fills a message structure MSG and copies it to the message queue of the thread. The message structure contains handle of the process for which the message is intended, means receiver ID, and the message parameters and the time at which the message is posted. So from which device or to which device we are sending the message, like our SMSs, we are sending the receiving person number, okay, and data. Just tomorrow exam is there, or tomorrow holiday is there, or tomorrow is the deadline for doing some work, like that. The receiver receives the from which device it is receiving the data, means transmitter phone number, so the person phone number and the time at which the person is posting the message, like our SMSs. Okay, like this, by using message passing, the processes will share the data or information among them. So a thread can simply post a message to another thread and can continue its operation, or it may wait for a response from the thread to which the message is posted. So the messaging mechanism is classified into synchronous and asynchronous based on the behavior of the message posting thread. Asynchronous means they simply post the messages. No need to waiting for response from the destination. Means in asynchronous messaging, the message posting thread just post the message to the message queue and it will not wait for an acceptance from the thread to which the message is posted. Just broadcasting, like our television channels or YouTube channel. simply post the message. No need to waiting for others' response. Like broadcasting. In synchronous, the thread which posts a message enters the waiting state and wait for the message result from the thread to which the message is posted. So the data is transmitting properly or not. For the acknowledgement purpose, the transmitting process is waiting for response from the receiver. Next, mailbox, like our mails in Gmail, whatever maybe we are using here. Mailbox is an alternative from the message queue, and it is used in certain real-time operating system for inter-process communication. Mailbox technique for inter-process communication in real-time operating system is usually used for one-way messaging, like our mail, Gmail. Just we are sending broadcast the messages. Like the format, we can follow the PPT format. Everyone should follow that format to the group mail ID or some mail IDs. The task or thread which wants to send a message to other tasks or threads create a mailbox for posting the messages, like college email ID, personal Gmail ID, or different types of mail IDs. The company mail IDs. The threads which are interested in receiving the messages posted to the mailbox by the mailbox creator thread can subscribe to the mailbox. Okay. If you want to get the updates from the mailbox, you can subscribe that one. The thread which create the mailbox is known as mailbox server, and the threads which subscribe to the mailbox are known as mailbox clients. Like in your YouTube channel, whoever the posting the information, those are servers. The readers are the clients. The mailbox server posts messages to the mailbox and notifies it to the clients which are subscribed to the mailbox. If you subscribe the YouTube channel, we can get the updates. The clients reads the message from the mailbox on receiving the notification. Okay. If you are activating the notification, means we will get the notification. We are getting mails. We are getting the updates. Whatever the updates we are getting here. So this is server which wants to broadcast the information, whatever the information it wants to share, it will broadcast into the mailbox. From that mailbox, the users or clients subscribe to that mailbox, they are getting the informations. Task 1 is act as a server which posts the message to the mailbox, like post the information to the group mail. The receiver, whoever persons available in that group or subscribe that group, they are getting that mails, either NPTEL mails. If you are subscribe the NPTEL group mail, then you can get the mails from the NPTEL team. So task 2, task 3, task 4 are the clients here. Let us consider here. So which reads the information from the group mail. The mailbox creation, subscription, message reading and writing are achieved through OS kernel provided API calls, application programming interface calls. So that depends on the kernel, real-time operating system kernel, which provides various types of application programming interface calls. Mailbox and message queues are same in functionality. The only difference is the number of messages supported by them. Both of them are used for sharing the data. Just imagine, what is the difference between SMS and Gmail? In SMS you can broadcast, but the data is limited. We can send fixed amount of data, either 600 words or 400 words, like that. 400 words is the data size limit. In case of mail, whatever the images, whatever the text data, whatever the audio files, video files, we can send up to 25 MB in case of Gmail. That is the only difference between a mailbox and message queues. Mailbox is used for exchanging a single message between two tasks or between an interrupt service routine and task. Mailbox associate a pointer to the mailbox and a wait list to hold the tasks waiting for a message to appear in the mailbox. The implementation of mailbox is OS kernel dependent. The OS implements mailbox as mechanism for inter-process communication. Signaling. So by using signaling, we can share the information. Example, traffic signals. If red light is there, means that indicates, that meaning is stop the vehicles. Yellow color means be ready for start the vehicle. Green means you can go ahead like that. Here also, signaling is a primitive way of communication between process and threads. Signals are used for asynchronous notifications where one process fires a signal indicating the occurrence of a scenario. Suppose if any object comes in front of the vehicle, that indicates some signal. So object is coming in front of the vehicle. Then the ABS, anti-lock braking system, will activate automatically. Or whenever any accident occurs, that indicating some signal, accident occurring is some signal. At that time, airbags will be opened automatically without human interaction. Okay. So that indicating scenario which the other process is waiting. Signals are not queued and they are not carry any data. Okay. The communication mechanisms used in the RTX, real-time Linux, RTX 51, that is the TinyOS operating system, is an example for signaling. The aimed signal kernel call under RTX 51 sends a signal from one task to a specified task. Similarly, the OS wait kernel waits for a specified signal. So, this is the one signal information, OS wait kernel call. The VxWorks RTOS kernel also implements signals for inter-process communication. That is kernel dependent. So, VxWorks is one of the operating system we are using here. RTX 51 TinyOS is the one of the operating system. So whenever a signal occurs, it is handled in a signal handler associated with the signal. So by passing the signals, we can do some operations. Whenever accident occurs, open the airbags, lock the wheel, ABS will be activated. Among various processes, we can share the data by using pipes. So there are two types, shared memory and message passing. In the shared memory, by using pipes. In pipes, anonymous pipes, unnamed pipes. Another one is named pipes. In named pipes again, unidirectional way we can share the data. In the bidirectional manner, we can share the data. In case of message passing, by using message queues, we can share the data. By using mailbox, we can share the data. By using signaling, we can also share the data.
Like, share and subscribe. Hit the bell icon for more updates.